Hello, lesson 10.5, solving systems by multiplication. Today our learning target is to use multiplication and addition combined to solve systems of equations. This is another form of elimination where one of the variables is eliminated immediately, leaving an equation with just one variable to solve. So, solving systems by multiplication, elimination. This is really an extension of the addition that we learned in 10.4. If we take a look at the system of equations that has been provided, the addition method from 10.4 is actually not going to work here because we don't have any opposite terms in either of the equations. And in lesson 10.4 we talked about how we could multiply through by a -1, but we actually don't have any equal terms where making one of them a negative would cancel out. So today what we're actually going to do is we're going to force the two equations to have opposite terms by multiplying one or both equations by a factor. So for example, when I take a look at this particular system of equations, I'm noticing that the 8d and the -2d, while they're not exactly opposite terms that would zero out, one is positive and one is negative. If I were to multiply the second equation by 4, it would result in the equation 16c minus 8d equals 112. By multiplying the second equation of the system by a value of 4, we end up with what we talked about in lesson 10.3, where we have a case of exactly opposite terms that when added will zero out. So if we add the equations together to eliminate one of the variables, the d variable does eliminate because 8d plus -8d is 0. So here we can see that we have 18c equals 180. 18c, of course, comes from the 2c plus 16c, and the 180 comes from the 68 plus 112. A quick division tells us that c is actually equal to 10, so we have solved the resulting equation for the remaining variable. Now that we know what c is equal to, we can use either of the original equations for step 4 to find the value of d. In this particular instance, I decided to use the first equation because it didn't have a negative d term. It wasn't minus 8d, it was plus 8d, and that seemed easier to me. Either one can be used. So you'll see me using 2c plus 8d equals 68. However, instead of a c, I will use 10, arriving at 20 plus 8d equals 68. By eliminating that constant, adding a -20 to both sides, we see that 8d is equal to 48. And finally, that d equals 6. As always, you do want to check your solutions. When checked in the first equation, it works out to be that 68 equals 68, so that's valid. And when c and d are checked in the second equation, it works out that 28 equals 28, and it is valid in the second equation. The rest of the notes that you'll see in the video are simply additional examples of this. You can write them down now or write them down later, but you will be seeing some additional examples of this in both the online version as well as what we do in class. So in our next example, we are going to again extend what we did in lesson 10.4. Looking at our systems of equations, we don't have any opposite terms between the first and the second equation. We also don't have any variable terms that are identical, where we could simply change one to the other. We've got two different options here. In this case, since the b's, there was one positive b and one negative b, by multiplying the second equation by 5, we end up with 2a minus 5b equals 31, and 40a plus 5b equals 95. Again, the green just represents that the two green parts are equal and the two orange parts are equal. So by adding a green with an orange on the left and on the right, we're adding the two equal parts, and we come up with 42a equals 126. 42a because 2a plus 40a equals 42a, and -5b plus 5b equals 0. 126 because 31 plus 95 is 126. And if we want to solve this for a, we would divide both sides by 42, arriving at the conclusion that a equals 3. Now that we know that a equals 3, we can use either equation to find out what b is. Since the second equation actually had a plain b in the equation, I decided to use that one. So instead of 8a plus b equals 19, we see 8 times 3 plus b equals 19, which gives us 24 plus b equals 19. By adding a -24 to both sides, we find out that b equals -5. Of course, as always, we should check our solutions. When a equals 3, b equals -5 is used in the first equation. 31 equals 31 is good. And when a equals 3, b equals -5 is used in the second equation. 19 equals 19, and that's amazing. Before coming to class, you should actually attempt to write the system of equations suggested by number 1. We all need a little bit more practice with writing the systems of equations. And numbers 2 and 3, you can go ahead and attempt these on your own, preparing yourself for class by, I guess, allowing you to see where your confusion might be and what questions you might want to ask when I see you next time. Have a great day.